Implication is an if-then function. So if you have P implies Q, what that means is if P, then Q. So for example, in an exam situation, and this is the one I like to use to remember the truth table for implication, is if P is the proposition that you pass your exam, and Q is the proposition that your mum buys you jeans, then the implication P implies Q is if you pass your exam, then your mum buys you jeans. So let's have a look at our truth table. We know we've got true, 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 false, false, true, false, false. Now, I like to look at this as a broken promise. Now, I always look at the left-hand side of the implication as your exam, because you have to pass your exam first. And the right-hand side is the jeans. And you can equate this to any left and right. So P implies Q, and think of it as broken promises. If you passed your exam and your mum buys you jeans, have you broken your promise? No. So the statement's true. If you pass your exam but your mum doesn't buy you jeans, then she's broken her promise. So she told you a lie or a falsehood. However, if you don't pass your exams and your mum still buys you jeans, is that a broken promise? Well, technically no, because she didn't say if and only if you pass your exam. So it's bad parenting, but it's not a broken promise. So she hasn't lied. And finally, if you don't pass your exam and she doesn't buy you jeans, she hasn't lied, so she was telling the truth. And that's the truth table for your implication. Now, this can be implied for any type of implication. So, for example, if we had the statement P implies P and not Q, if we draw up our truth tables, first we need P and Q, but we're also going to need a not Q in here. We're also going to need to know P and not Q, in other words the bracket, and then finally we can come up with the truth table for the implication. So remember, we're starting with true, 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 false, false, true, false, false. Now not Q, so if Q is true, this is false, Q is false, this is true, false, true. And remember, this symbol is and, so for this to be true, P and not Q have to be both true. So we've got true, false, so that's false. True, true, so that's true. False, false, so that's false because they both have to be true. And false, true is also false. Now we're at the position where we can look at the implication. Now the left-hand side of the implication is always the exam, because that's what we have to do first. So I write a little exam up there, and the right-hand side, which is the bracket, is the jeans, whether or not you get the jeans. Okay, so let's look at this. You pass the exam, you don't get the jeans. Broken promise. So your mum's told you a falsehood. You pass the exam, you get the genes. Not a broken promise. She told the truth. You don't pass the exam, you don't get the genes. Again, no broken promise. And the same again, you don't pass the exam, you don't get the genes. No broken promise. So that's the truth table for this implication. So if you consider every implication as the left-hand side is the exam, the right-hand side of the genes, you can always consider it in terms of broken promises.